Good afternoon, everyone. Please get around. The show's about to start. Okay, so I hope you had a nice lunch. I really enjoyed it. We don't get to eat by the pool much these days in Canada. So welcome to my session on entitled Better Quality, Less CPU Usage, Hardware Acceleration for Asterisk Application. My name is Guillaume Renaud, and I work for a company called Octasic. And just before we start, so the goal of this presentation is pretty much to argue the point that using hardware acceleration in your Asterisk applications yields better quality. It doesn't necessarily mean you can do a lot more stuff, but the stuff you do is done better. And so the end result is better quality products. Just a quick show of hands survey. How many of you here, it's their first Astricon? Wow, lots. Second? Third? Yay. More than that? Okay. So the veterans are there. Well, welcome. And a lot of integrators in the room? Or, yeah? Developers? Hardware manufacturers? Good, because I'm not actually here to sell you chips. Excellent. So now that I know a bit more about you, here's a bit more about me. So I studied at École de Technologie Supérieure in Montreal, or ETS, which is an engineering-only university. I graduated in electrical engineering, specialized in information technology in 2005. I then started working for Octasic as a validation specialist. I did lots of testing of our echo cancellation products and the voice quality enhancements, like noise reduction, level control, and that type of stuff. Then in 2008, I switched from the engineering side to the dark side, as we like to say, and became part of the customer and sales support team. And that's just a personal preference because I didn't enjoy that much 8 hours a day of coding. Like 2 is enough, and I need some more personal interaction in my work. So I started to do support. And as I said, I attended the Astricon. This is my 3rd time, so I was there in Phoenix and last year in Denver. Now, let me tell you a bit about Octasic. Any people here familiar with Octasic, or? Oh, good. So Octasic is a fabless semiconductor company. That means we do chips, devices, we design them, we do the software that runs them, we market them, we support them, we sell them, everything we do except fabricating them, because owning a fab for silicon is quite expensive. So we have partners for that. And Octasic started in the beginning. The first Octasic product was a device that was transporting or converting TDM to packet, mostly ATM for carriers at the time, but also IP. So that was the first, let's say, commercial success. But the real big moment for us, and that stemmed from that first product, is since these people were doing voice over IP, there was a need for echo cancellation that was answered by other people, but we thought not so well. So we decided to revolutionize the echo cancellation, and that's where the AUX 6100 was born. So this is a TDM echo canceller. It can cancel up to 672 channels in a single small device like this at under 2 watts. So that was pretty disruptive when it came out in 2003. And yeah, people didn't believe that. What do you mean a new company is going to start off with a new echo canceller? That's never going to work. And today we pretty much own the market. So, and then we followed up with this. So a lot of people were using our packetizer chip, the TDM to packet chip, in conjunction with the echo canceller. But then they would put DSPs next to it to do the voice encoding of 729, 723 mainly. So that's where we decided our next project was to do a solution that contained all of the above. And that's what we call our Vocalo Media Gateway. Yeah, the Vocalo Media Gateway is the firmware we put on our DSPs, because our DSPs are based on our DSP cores that we developed ourselves. They're using asynchronous technology, but mainly so we load. We also designed the Media Gateway firmware that does what the previous products did, but also including the voice codecs. Another big leap for us was to move from being a strictly ASIC company to a programmable device company. So we're shifting from mostly hardware towards a software company because our platform are now programmable. And also, since it's fully programmable, we're continuously adding new features to our Media Gateway firmware. We support video, and now up to 1080p with the latest generation device, second generation device of DSPs, the 2224. It's called 2224 because, well, the first one had 15 asynchronous DSP cores, the new one has 24. And this one, the 2224 was introduced in 2010, and it's starting to be deployed right now. And also, it's being used, the DSP technology, in side market, so not the Media Gateway, but it can be used to do baseband processing, basically the layer 1 modem of base stations. So that's our new adventure. Now about where we fit, so the echo canceller was present in mostly gateways, enterprise, media gateways, access gateways. The DSP, the Vocalo, is also used there, but on top of that, we can now do video conferencing, video streaming, and a lot more of the job on the base stations, as I hinted earlier, because it can be used as a media gateway chip or DSP or baseband processor DSP. So yeah, that was my intro part, and if you have more questions about Octasic and products, feel free to come and see me and stop me anywhere during the conference. Because here the goal here is to talk about better quality and Asterisk applications. But to start, we'll take a little trip down memory lane and how this whole adventure started with the Tormenta ISA card, which was the first adaptation card that enabled you to take the TDM samples from PSTN and throwing it to a CPU. Because there is a Moto still up there on the web page. The idea was there were cards available on the market to do that at the time, but they were, one, very expensive, using lots of DSPs, that's why they were expensive, and the quality was not so good, apparently. So the need to answer here was we wanted affordable computer telephony, and then so Zaptel, Asterisk started a bit like that. But as I was saying, on the webpage of the Zapata telephony project, it says we don't need no stinking DSPs, meaning that was the goal of the project, to remove the DSP part of the adaptation cards and throw it all to let the CPU do the job. Because, of course, we can do pretty much anything in software with a general purpose CPU. But then the echo problem comes up because, as you know, Zaptel Asterisk, it's all about VoIP. And so where does echo come from? Do we have a crowd of echo experts in the room, or you have no idea? You just know it's present, and so like echo haters, but okay, but you have to know your enemy. So where does echo come from? Echo comes from the hybrid transformer. And what does the hybrid transformer do? It takes a 4-wire analog channel and puts it down to two wires. So it's doing an impedance adaptation, but as anything analog, it's not perfect. There are some reflections. And that's where the echo, so that's the reflection point for the echo. Anybody know why we use these and have 2 wires for the legacy, yeah. But it's part of the history of installing the PSTN. It's for the last mile. That's the majority of the length of the networks, the circuit. And installing like 4 wires as opposed to 2 wires was twice the cost in copper. So somebody found a nice solution. We can have because you want to have the reliability of the 4 wires in the core network, but then for the last mile, we could just connect them at 2 wires. So that's where the hybrid came in. And now they're in every single interface card that has analog parts. You have the 4-wire to 2-wire, and then it connects outside. If you're using digital cards, somewhere down the line, there is a 4-wire to 2-wire conversion, an hybrid, before it connects, and that's where the echo comes from. So that's the first ingredient of echo, the reflection point. The next one is delay. And so, as I was saying, Asterisk and Zaptel is very much about VoIP, and VoIP, it's great, but it does add delay because you have to encode, packet, and then send out the packets en route and hope for the best. But that means that before, you needed echo cancelers for long-distance calls when it was all a wire connecting you, because echo below 20 milliseconds will not disturb you. So there was some echo in local calls, but it's okay. It's within the respectable limit. But when you put a VoIP, just a call within the same town now has more than enough delay for the echo to become perceivable. So that's why we need echo cancelers everywhere now. So our solution was, and the solution of the Asterisk community is to start installing hardware echo cancelers on interface cards to handle the problem. And the gains are twofold, meaning you're offloading CPU cycles to this hardware accelerator to do the echo. That's a good part. The other part, in the design of Zaptel and Asterisk, there was the constraint to have every sample would be sent to the application as fast as possible to handle the echo in software. Using a hardware echo canceller, you don't need that much of a, you don't need to be sending every sample and interrupting the CPU, context switching every time you have a sample. Now you can increase the chunk size, and just with that, increase your channel capacity. Even if you don't, with bigger chunk size, you already see a good increase. So that's the history so far of hardware acceleration in Asterisk application. What's going on today is now we're leveraging the power of the DSP with Vocalo or other DSPs to do voice transcoding. So some of my some examples are here, and that's the simple need just to translate from one codec to another, which can be done again on a general purpose CPU, but then you lose some CPU cycles doing that, and you cannot have more channels or better applications. So the result of using these DSPs to do the voice transcoding is yet more channels. And then, again, the latest development is the emergence of the VoIP gateways, where we're putting, some are putting Asterisk in the gateway just to handle that part, and includes DSPs to do echo cancellation, voice transcoding, and everything. The result is better Asterisk solution in the sense that now you can have your Asterisk server running on a separate server, maybe virtual server, maybe, I don't know, somewhere in the cloud. But all it has to do is to have a SIP trunk to the gateway, and that's it. Your calls can connect to the telephone network. So again, there's nothing revolutionary about VoIP gateways, apart from the fact that it makes the overall solution more elegant, robust, and it sees more adoption by the market. We see a lot more people using Asterisk for their PBX system because such improvements that have been made to the solutions. So that's the present, and now I'm going to give you a small peek at what's coming. First, you are probably aware of these, but the wideband audio codecs are more and more in use. And of course, transcoding wideband audio because of the wider spectrum will for sure be more CPU intensive. So that's yet another good reason why you would want to have hardware acceleration in your application. So you can support all these wideband audio codecs and provide a better experience to your users. The other field that's coming, it's video transcoding. Although it can be hard to do a simple, a bit like the graphic shows, a simple point-to-point SIP call with video, you could just bridge the call between the two endpoints and have them use the same codec. But there's some situations where it's not possible, and we've been asked to do the transcoding there. It could be just because of the CPU usage, because I don't know if you've had to play with video a bit. When we're familiar with how many, let's say, voice channels this type of CPU we do, and then you look at the numbers of video channels it can do, the drop is quite dramatic. So every CPU cycle saved for video is welcome. The other one is the famed video multi-point control unit, or video MCU. So to enable a video conferencing application, where there's no possibility of even thinking of bridging the people together from the endpoints. You need somewhere a point in the network, and ideally you need hardware that will take the different streams that are maybe different codecs used by the participants. But even if they use the same codec, they probably don't have the same resolution or frame rate and that type of thing. And then you want to mix them together, these four inputs, assemble them in a mosaic, and send them out encoded. So the picture shows once, but a lot of video MCU requirements are every user wants the flexibility of maybe looking at it full screen, the speaker or the presentation, and then switching to seeing everybody. So for these features, you absolutely need DSPs to do the multi-point control unit. And yeah, then before I conclude, I will just I'd like to part on words of wisdom that guide me every day in my work, and that, of course, support my idea that the better your application is, the more your users are happy, the better world we're making, right? So I don't know if you ever read Arthur C. Clarke, one of my favorite science fiction author, said that any sufficiently advanced technology is undistinguishable from magic. And that's what I always aim to do, to get the products to the level that the user are just impressed and feels like magic. So with that, I thank you, and I'll open the floor to questions if there's any. Well, thanks a lot, and as I said, feel free to come and see me or stop me if you see me on the conference floor. And have a good continuation. Thank you. What's large? Yeah, most of them.
400 users on a
yeah, 6100 does conferences up to, I don't know, there's a max user, but yeah, and Vocalo does it. Yes, it's part of our audio offering. Audio conferencing is built in.
And what would be like the savings in CPU, like to offload that? What part of it is offloaded? How much of the work is done on the card?
I guess it would boil down to how much CPU is used for the mixing of the audio, which I would guess is not that much. Because the mixing of the audio, it's basically everything is decoded to linear, and then you just sum it. With video, it's a bit more complicated, because then you have to, as is shown here, you have to resize them, you have to position this guy there, so that's a lot of processing. So I don't know if the conference is the, I mean, it's doable, absolutely, and some of our customers do it, but in the Asterisk specific market, I don't know if we would have the flexibility of, but maybe, yeah, maybe that's something to look at. That could be a good application for sure. It's totally doable. Yeah, and for on the Vocalo, it's nice. You can have like all different codecs coming in the conference, and it's just connecting them to the conference makes transcoding magical. So, any other questions? Yes.
You got a slide go by. It had there was a board, an add-in card. You could drop it in an Asterisk machine and do transcoding. Correct?
This one, you mean?
Yes.
But that's it. I'm not. It's not my board.
Okay. Oh, that's not your.
No. Octasic only does chips,
Right.
just devices. So, but I mean, a lot of our customers are here today. So,
Is that a Guillaume product, perhaps?
yeah, and actually, this is a Digium voice transcoding card that doesn't use Octasic DSP. It uses some other DSP. It does 723 and 729 encoding. This is a Sangoma card that uses Vocalo. Thank you.